Hello students, welcome to Vyas Education Kota. In this series of NCERT discussion, we'll continue further with Mathematics class 11th. The chapter that we're dealing with is Sequence and Series, and today is the turn of exercise 9.4. One very important exercise from the point of view of all examinations. You consider the board examination or you consider any competitive exams. This is very important exercise because lots of questions have been asked in the past from this. And lots of interesting questions have been asked, right? What all is covered in this exercise? Some summations, some general summations, that is summation of n, where n goes from 1 to some natural number, basically summation of all natural numbers, summation of squares of natural numbers, summation of cubes of natural numbers. These are some of the concepts, and along with that we also learn something called method of difference. Okay, NCERT people don't talk about method of difference in general. They don't exactly specify this word method of difference, but then the questions asked and the questions given in the exercises examples are based on something called method of difference, right? So along with the questions, we'll be seeing the concepts that are involved in those questions and you'll be revising with us. Okay, so let's take a look at each and every question one by one. The first question says, find the sum up to n terms of each of the series in exercises 1 to 7. Okay, 1 into 2, 2 into 3, 3 into 4, 4 into 5. These are the terms. If you observe, this is one term, this is the next term, this is the next term, this is the next term, right? So, how will we find the sum of this particular series? Finding the sum is very easy if you can write the nth term first. Write the nth term, okay? How will we write the nth term? This is T1, this is T2, this is T3, this is T4. Let's represent the terms with the number T, with T, not with A. We can represent with A as well. We could have said A1, A2, A3, A4. That's also okay. The notation can be A1, A2, A3, A4 as well. We are using T1, T2, T3, T4. Okay, so what does T1 look like? For T1, do you observe that this first number is 1? Okay, then the second number is 2. For T2, this first number is 2. T3, the first number is 3. T4, the first number is 4. That's what you can observe, right? Okay, and if you observe this carefully, then what do we say? That in Tn, when we have, let us say, somewhere here, if you have Tn, in Tn, the first number, there will be product of two numbers, the first number will be n, and the next number is 1 plus 2, 2 plus 1, 3 plus 1, 4 plus 1. So, the next number will be n plus 1. This is what you have. That's the first and foremost important step, which says that you should be able to write the nth term in this manner, right? If you can write the nth term properly, then you can continue further and find the summation easily. How will we find the summation? Let's take a look at that. So finding the summation, there are actually two methods. One of the methods has been discussed in NCERT. We'll be talking about that method first. Then I'll also tell you another method later on, right? So let's take a look at the first method. When we want, the second step will be to find Sn. Sn will be summation of Tn from n is equal to 1 to n. This is what you have, okay? What does this imply? This particular summation symbol implies that n starts from 1, you get T1, then you get T2, and summation implies that you put a plus sign between them. And the value of n goes up to n, right? This is what you can write it as. Sometimes we also prefer, instead of writing this n over here, we use R. The notation that is used is R. For TR, just a minute. The notation that is used is TR. So summation of TR from R is equal to 1 to n is what we are interested in, and yes, that's what we are interested in. This is the expression. Okay, here we could also have written, or we could have written TR is equal to R times R plus 1. This is what we could have used, right? This is the other thing. Once you are clear with this much idea that we have found TR, we have written the summation of TR up till n terms, and that is represented by Sn. Okay, and this symbol actually means this. Okay, but now I'll come back to this expression over here and simplify this. Summation of TR from R is equal to 1, so like 1 to n. TR is actually R square plus R. What have we done? I've simply multiplied that R inside. And how does that help? That simply helps that now I can separate the two summations. r square, r is equal to 1 to n plus summation of r is equal to 1 to n. That's what we are interested in, right? And these are two very standard summations. This is summation of r, which says, okay, 1 plus 2 plus 3 plus 4 plus dot 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 up till n is what we are interested in. This says 1 square, 2 square, 3 square, add them plus dot 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 up till n square is what we are interested in over here. So what are these summations? Summation of r from r is equal to 1 to n is actually 1 plus 2 plus 3 plus dot 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 up till n, and that is equal to n plus 1 by 2. This is equal to this. Summation of r square, r is equal to 1 to n is 1 square, 2 square, 3 square, dot 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 up till n square, and that summation is equal to n times n plus 1 to n plus 1 upon 6. This is equal to this. And there's another standard summation, summation of r power 3, which goes from r is equal to 1 to n, and that is equal to 1 power 3 plus 2 power 3 plus similarly dot 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 up till n power 3, and that is equal to n square, n plus 1 square upon 4. And if you can observe, if you observe carefully, this is exactly same as square of this. Yes, that's the important observation. This is basically summation of r is equal to 1, or you can write it in terms of, right? Let's not write this. Let's write n times n plus 1 by 2 and its square. That's what we are interested in, right? That's the summation. Okay. So these three results are important. Yes, these three results are very, very important. Okay. So I'll replace some sigma r square from r is equal to 1 to n by this, and I'll replace sigma r by that over there. What is this equal to? This sigma is equal to n times n plus 1 to n plus 1 by 6 plus this is n plus 1 by 2. If you see, we have obtained the summation. That's not an issue. We have found the answer, but can we simplify this further? Yes, we can simplify this further. And how do we do that is interesting, important to note over here. From the numerator, take as much as possible common. Similarly, from the denominator, take as much as possible common. Okay. So what are we doing? In the numerator, I see n plus 1, n plus 1 common coming out. So this becomes n plus 1. In the denominator, I say 2 and 6. The LCM would be 6, right? So from the numerator, I have actually taken the highest common factor, and from the denominator, I have actually taken the lowest common multiple. Oh, is it? Yes, that's what we have done. And what do we get in the bracket after this? So n plus 1 upon 6 has come out common. 2n plus 1 will remain over here. Plus n plus 1 by 2 is there, and you have taken out 6 common. So 3 will come in the numerator. This is what you'll get. Okay. And what does this simplify to? This is n plus 1 by 6. This is 2n plus 4. You can take out a factor of 2 common. This becomes n plus 1, n plus 2 upon 3. That's my required answer for this question number 1, as you can see over here. Okay, that's sufficient for this particular question, but then, sir, we also mentioned something called another method for solving this question. Yes, another method for solving this question and certain other questions. How can we do that? So let's take a look at another method now. What did we have? TR. I'll start with this TR. TR was R times R plus 1. This is what we started with, right? TR was R times R plus 1. Is that okay? Yes. Once you are clear with this, then I would like to write TR as difference of two terms. Difference of two consecutive terms. Okay. How do I want to write TR? In general, I want to write TR as VR minus VR minus 1 in this particular form, or VR plus 1 minus VR, this kind of a form. This or this, whichever. If you can do this, if you can do this much, then if you can do that, then what happens after that is you write T1 easily. This is V1 minus V0. T2 will be V2 minus V1. T3 will be V3 minus V2. Okay, and similarly, if you write up till Tn, what do we get? Vn minus Vn minus 1. Okay. And what do we want to do? We wanted to find the summation up till first n terms, right? Summation is the sum of all of these, right? So Sn, which is sigma T r is equal to 1 to n, will be summation of all of this, right? We add all of them. And what do we get on the right hand side? On the right hand side, we add V1 minus V0 plus V2 minus V1 plus V3 minus V2. And do you see that this plus V1 and this minus V1 will get cancelled? Yes. This plus V2 and minus V2 will get cancelled. Yes. Similarly, plus V3 over here, and in the next term you get minus V3, which will get cancelled over here, right? And if you continue further, just like this Vn minus 1 will cancel with this Vn minus 1 over here in the previous term. Yes. Okay. So what remains? What remains is, from this particular term, this remains, and from here, this particular thing remains, right? So two consecutive terms, difference of two consecutive terms, yes, and they get cancelled on adding, and what you get is Vn minus V0 at the end, which is pretty simple, don't you think so? Yes, this looks pretty simple. So this is how we can find the summation, okay? What happens in this case, you can observe in this case also a similar thing will happen. You get V2 minus V1, V3 minus V2, and V1 will remain and everything else will get cancelled. In the last term you get Vn plus 1 and that remains and everything else will get cancelled, right? So the key is to write TR as difference of two terms somehow. Can you do that? The bigger question is, can you do that? So I'll tell you some ideas. I'll discuss some ideas. Yes, I'll discuss some ideas for writing such kinds of terms as difference of two terms. Okay, what are the ideas? Let's take a look at the idea. When you have r plus 1, product of two consecutive numbers. Can you see r and r plus 1 are two consecutive numbers? Yes. So product of two consecutive numbers are there. Or to go a step further, if you have such products of numbers which are an arithmetic progression. What do you mean by that? Arithmetic progression simply means here the common difference is 1, but the common difference could as well have been 2. You could have had product of 2 terms or product of 3 terms as well. Product of 4 terms as well, yes. You could have had any of those things. And what will we do in this case? Let's take a look at this. If you have this kind of a thing, then r plus 1, imagine the next term what will it be in among these? r plus 1, what will be the next term? Had I continued writing these terms, the next term would be r plus 2. That's okay, that's not an issue, right? That's pretty simple. The next term will be r plus 2. And what will be the previous term? What do you mean by previous term? Previous term, this is the next term of these. The previous term, I'm talking about the term before r. Why are you solving that term? Let's see. The benefit will be clear to you in a minute, but if I can find this previous term. So previous term is not difficult, r plus 2, r plus 1, r, and then previous term will be r minus 1. Will it not be? Yes, this will be r minus 1. Okay. You actually multiply with difference of these two. Okay. So difference of these two will be written in a bracket, yes or no? Yes. You actually multiply with the difference of these two, that is this. Next, minus previous. This is what you have, right? Okay. So are you multiplying with something over there? Yes, I am multiplying with something. Will you not divide by something? I will divide by that. Otherwise, how will we maintain equality? Will not. R plus 2 minus r goes away and minus of minus 1 becomes 1. So 2 plus 1 is 3. I am actually multiplying with 3, yes. And division by 3 is not difficult, yes. I can divide throughout by 3, right? Multiply by 3 and divide by 3. So now, do you see that TR can be written as this 3 is there with r plus 1 can be multiplied here, r plus 1 can be multiplied over here as well, right? 3 will be present with both. 1 by 3 r plus 1 r plus 2 minus the other term will be 1 by 3 times r minus 1 r plus 2. Do you see the benefit of writing it this way? If you replace r with r plus 1 over here, you get this term, right? Just the next term is present over here. Okay. So have we written this TR as difference of two VR and VR minus 1? Can you see that? Yes. This is what you've done. And now finding the sum will not be difficult at all. How will we find the sum? T1 is simple. This is 1 by 3. T1 will be 1 into 2 into 3 minus 1 by 3 times 0 into 1 into 2. That is T1. What is T2? 1 by 3 times 2, 3, 4 minus 1 by 3 times, what is this? 1, 2, 3. Oh, I see this and this getting cancelled. Yes, this will get cancelled just like this. Right. And what will I get? Vn minus V0. Yes. So why not write Tn and see what is Tn? 1 by 3 n times n plus 1 n plus 2. This is Tn minus 1 by 3 n minus 1 n plus 1. This is what you have. Yes or no? Yes. This is what we have. And now if I add Sn will be equal to adding all of these, I see this gets cancelled. This will get cancelled with some term over here. And this here will get cancelled with some term over here. From the first term, this remains. So, from the last term, this will remain. And what we'll get is 1 by 3 times n plus 1, n plus 2. This is actually 0. Don't you see that? Yes. So, is that the final summation? Yes, this is the final summation. And that's the answer for this question. Oh, we just saw that. Yes, we obtained similar answer. But the calculations were a bit difficult over there. Yes, we needed summation of r square, we needed summation of r. But then final result was exactly same. Was it not? Yes. So you can verify that, okay, this method, once you can take a look at this complete method and assure yourself, okay, that this is pretty simple, not a difficult thing at all. Just have to multiply with next minus previous and divide by whatever comes over there, right? When you get terms like r plus 1, something of this sort, right? This, let's verify the answer 1 by 3 times n plus 1 times n plus 2. Was that same answer that we obtained over there? Yes, 1 by 3 n plus 1 n plus 2. It's the same answer, right? Okay. Is that simple? Yes, that's pretty simple. And can we apply this approach in similar questions further? Yes, we can apply similar questions further as well.